Hi, in this video, we want to consider some important ideas and general ideas that with those ideas you can solve many problems. For example, one of them is what Lagrange multiplier. This idea is so much useful in Singapore Mathematical Olympiad and other exams. This one, open section. We want to solve all these problems with this idea. And this one, senior 2021, all of them. And we want to see how we can calculate. And let me tell you, right after the exam, SMO 2022, if you had any question about the solution, please feel free to send message to my WhatsApp number in the description and comments. I released all parts of 2021, 2020, and 2019. And also I will release other years, but before them, I will release SMO 2022 whole solutions for open section, senior section, and junior section. So if you had any question after the exam, please feel free to send message to my WhatsApp number in the description and comments and ask, and I can explain for you. So let's solve. I want to explain for you this. There are some ideas that in SMO and other Olympiads are so much useful. One of them, Lagrange multiplier. We want to solve these problems with that. The other one is what for this problem. We want to consider for this one for open section 2020, considering a small example. So here, considering small examples, special cases, and consider one property, and then you can split up into different cases. This one we want to solve with considering a small example for open section, this one for senior, and considering one property and split up the answer into smaller one, we want to solve this one. Okay, so let me explain for you how you can use Lagrange multiplier. It's so much general in the problems, and sometimes AMGM you can use ascending, descending, but this one is more general when you have condition. So here, when you have condition, consider that G, and G should be 0. So our condition here is what? X minus 5 squared plus y minus 7 squared minus 4. You take all things to one side. It is 0. So the first step, you should define G. That it's the condition that it equal to 0. You should take all things to one side. The next one, you should say, okay, the thing that we want to find minimum or maximum, F. Here it is what? X plus 7 squared plus y plus 2 squared. Then we say what? We define L, that it is equal to F minus lambda G. And then you say what? You say, okay, it is X plus 7 squared plus y plus 2 squared minus lambda G, which is minus lambda X minus 5 squared minus lambda y minus 7 squared plus 4 lambda. Now, you should differentiate from L with respect to X and also differentiate from L with respect in terms of Y, because we have two variables. If you had three variables, we should calculate all of them. So here, if we differentiate, it will be 2 times x plus 7 minus 2 lambda x minus 5, and all of them will be 0 here. And it should be 0. If you don't have any condition like G, the general form is you differentiate from this and you say it is equal to 0. But when you have condition, you should do these things. If you differentiate, sometimes you should replace. Substitution works. Substitution in many problems of SMO works. During this video, I will tell in each part, I will tell what are the important and useful ideas you can use. If you differentiate from y, it will be 2 times y plus 2 minus 2 lambda times y minus 7 is equal to 0. Now let's see what can we do here. We say lambda equals what? You can cancel these two. You can cancel these two. You can say, okay, lambda equals, let me write at first here. You'd say, okay, if we cancel these two, x plus 7 equals lambda x minus 5. So lambda is what? Is x plus 7. We divide both sides by x minus 5. So here, maybe you say, okay, if x is equal to 5, then what happens? If x is equal to 5, then it is 0. And here it will be 12 and contradiction. The next one, similarly, you can divide both sides by 2. And y plus 2 is equal to y lambda y minus 7, and then you can say, okay, lambda equals y plus 2 over y minus 7. In both of them, we have lambda, so these two things are equal. Okay, so here we have these two equations. Lambda is what? Lambda from one side, you can say x plus 7 over x minus 5 equal to lambda and equal to y plus 2 y minus 7. If we cross multiply this one, x plus 7 times y minus 7 equal to x minus 5, this one times y plus 2. And now if we multiply them, it will be xy minus 7x plus 7y minus 49 equal to xy plus 2x minus 5y minus 10. Now we can cancel xy from both sides, and then we can take negative 7x to right side. It will be plus 7x plus 2x. It will be 9x. And you can say, okay, 49, take it to right side. Negative 49, it will be 49 minus 10 plus 39. Okay, we've calculated this. Now y is left. 7y here. Take negative 5y to left hand side. It will be 12y. And now if we divide both sides by 3, then we have 4y equal to 3x plus 13. Okay, now we had a condition. In Lagrange multiplier, when you reach the relationship by considering differentiation, then you use the condition you had, assumption. So here we say, okay, y equal to 3x plus 13 over 4. And if we replace here, we have x minus 5 squared plus y, replace y with this 3x plus 13 over 4 negative 7. Look, maybe for each problem we can find a tricky way that is shorter, but when you solve with a Lagrange multiplier, it is more general, and I can say 30 or 40% of these types of problem in SMO, Singapore, or other countries is useful. AMGM, as I said, there are Cauchy-Schwarz, there are lots of things, but for example, Cauchy-Schwarz, one problem, AMGM, one or two problem. But in each year, as I showed you, you can solve and use this idea. General ideas are so much useful. So here, I say x minus 5 squared plus, if I factor, it will be 3x plus 13 minus 28, 4 times 7, 28, over 4 squared is equal to 4. 13 minus 28 is negative 15. You can factor from 3 here. So it will be x minus 5 squared plus 3x minus 5 all over 4 squared equal to 4. Then we can say, okay, it will be x minus 5 squared plus 9, 3 squared over 4 squared, 16, times x minus 5 squared equal to 4. Now we can say what? If we factor from x minus 5 squared, then we can say 1 plus 9 over 16 equal to 4. 1 plus 9 over 16 is what? If we use common denominator, it will be 16. 16 plus 9, 25. So times 25 over 16 is equal to 4. Now we can say x minus 5 squared. If we multiply both sides by 16, it will be 64. And divide both sides by 25, it will be 25. Now we can conclude what? X minus 5 will be plus minus root square root of this, which will be 8 over 5. So x will be 5 plus minus 8 over 5. So one answer is this plus this, and if we use common denominator, 5 times 5, 25, plus 8, 33 over 5, and the other answer is 5 times 5, 25, minus 8, 17 over 5. Okay, one of them reach minimum answer, one of them reach maximum answer. We know what? We know y is 3x plus 13. Okay, now if I paste that condition here, then we have what? We can find y for each of them. For the next one, you say, okay, y is 3 times this. 99 over 5 plus 13 all over 4. It will be what? 99 plus 5 times 13, 65. And 5 times 4, 20. 99 plus 65 is 164 over 20. You can divide both sides by 4. It will be 41 over 5. And this one is for this. The next one, x is 17 over 5. Y 3 times this, 51 over 5 plus 13. All over what? All over 4 here. 5 times 13 plus 51. 51 plus 65. 5 times 4, 20. If you use common denominator here. 51 plus 65 is 6. 5 plus 6, 16 over 20. If we divide both sides by 4, it will be 2 times 4, 29 over 5. So here it will be y in this case is 29 over 5. The problem says find minimum value of this. So if you pay attention, because we want to find minimum, in this case, x is less than this one, but here y is greater than this one. Okay, so we should consider both of them to see which of them works. Here in this case, let me show one case is this, x and y, one case is this. So if we consider the first case, 33 over 5 plus 7 squared plus y squared, which is 41 over 5 plus 2 squared. 5 times 7, 35. 35 plus 33 is what? Is 68 over 5 squared plus 5 times 2, 10. 10 plus 41 is 51 over 5 squared. This is the first case. And the next case is to replace these two things. So here it will be what? 17 over 5 plus 7 squared plus 29 over 5 plus 2 squared, which will be what? 5 times 7, 35, 45, 52. 52 over 5 squared plus the next one is 5 times 2, 10. 10 plus 29, 39 over 5 squared. Okay, as you can see, 52 is less than 68 and 39 is less than 51. Okay, here also we could say this one is less than this one is less than this. So because we want to find minimum, we should consider this case, 52 over 5 squared plus 39 over 5 squared. So it will be what? It will be 1 over 25, 52 squared plus 39 squared. If we calculate 52 times 52, it will be 2704. So it will be 1 over 25, 2704. And then if we multiply 39 by 39, it will be 1521. And if you add up these two numbers, it will be what? 4 plus 1, 5, 2 plus 0, 2, 5 plus 7, 12. We have 1, 1 plus 2, 3, plus 1, 4. So you can divide it by 25, it is multiple of 25, or you can at first divide by 5, then it will be 8, 4, 25, 5. Then you can divide by 5 again, 34, 6, 45, 9. So the answer of this problem is 100. Okay, we've solved this open section 2021. You can solve it. This one is so much easier. You can solve this one with this idea also. This one 2019, this 2019, because I want to solve from different parts. All of them have condition, and then you should find minimum and maximum, and all of them have also other solutions. But I want to tell you one way, one idea that can solve a lot of problems. These ideas are good, and if you solve some problems, you can solve faster. Okay, now we want to solve from different parts. Here, for example, in senior problems, most of the time we don't have conditions. Okay, for example, this one doesn't have condition, but I want to solve a harder one, because if it doesn't have condition, you consider d squared and then differentiate from this, like d squared, and then differentiate in terms of x, differentiate in terms of y, and prove x is between x and y or between 0 and 1. You can solve this one as homework. Let's solve, for example, some problem. If you had any question, feel free to send message to my WhatsApp number in the description and comments. I want to solve this senior 2021 because it has condition, and most of the time the problems that have condition are harder. So let's solve this problem. Sorry, this one is for senior 2019. So let's solve this problem. Sorry, it is, let me correct, it is 2020. Okay, senior 2020, this problem. Again, we want to solve this with our useful idea, Lagrange multiplier. Okay, so let's solve this one. Again, we define G as what? A condition that it is equal to 0. X squared over 5 plus y squared over 7 minus 1 equal to 0. And then I define f equal to x plus y squared, and then I define L equal to f minus lambda g. Again, the same idea, like open section. We want to solve with exactly the same idea, problem of senior 2020 in open section 2021, 2020, and all around all the years, and also senior. This idea is useful. There are also some other ideas for other problems that are useful. If you had any question, feel free to send message to my WhatsApp number in the description and comments. So let's solve. X plus y squared minus lambda x squared over 5 minus lambda y squared over 7 plus lambda. Now we differentiate terms of x and also in terms of y equal to 0. It will be what? 2x plus y minus 2 lambda x over 5, only in terms of x. We differentiate and equal to 0. Now let's differentiate with respect to y. It will be 2 times x plus y minus 2 lambda y over 7 equal to 0. Now here we can cancel these two, and then we say x plus y equal to lambda x over 5. So lambda equals, we multiply both sides by 5x plus y over x. Maybe someone says, okay, if x equal to 0, if x equal to 0, this one, then y also should equal to 0, and it doesn't satisfy this condition. The next one, we divide both sides by 2 again, x plus y equal to lambda y, take it to right hand side, negative change to positive, lambda y over 7, and lambda equals multiply by 7, divide by y. Similarly, again, we can say y is not 0, because if y is 0, this is 0, so x equal to 0, x and y 0 doesn't satisfy this condition. Now, we know lambda equal this, lambda equal this. So from these two things, we consider right sides are equal. So 5 times x plus y over x equal to 7 times x plus y over y. Now, if we cross multiply, then we will have 5x plus y times y equals 7x x plus y. Now, if we take all things to left hand side, then I factor from x plus y. I have 5y minus 7x. So because it is equal to 0, we have two cases. Case 1, x plus y equal to 0, or 5y minus 7x equal to 0. The problem says what? The problem says find maximum of x plus y squared. So In this case, in this one, x plus y squared equal to 0, but we can prove, we don't need to check does it satisfy or not. In this case, we will find something greater than this. So at first we check both of them. In this case, 5y equal to 7x. Okay, we had this condition. From this, we can say, okay, y equal to 7 over 5x. And if we substitute x squared over 5 plus y squared, which is what? 7x over 5 squared over 7 equal to 1. So we can say x squared over 5 plus 7x squared is 49x squared over 5 squared is 25 times 7 equal to 1. We can cancel these two 7 and then we can multiply both sides by 25. We have 5x squared plus 7x squared equal to 25. So 12x squared equal to 25. So we can conclude x squared equal to 25 over 12. Okay, so we can say x equal to plus minus 5 over root 12. And y equals what? 7 over 5x, which will be plus minus 7 over root 12. Now, here we want to find maximum of x plus y squared. Because we want to find maximum, we should select same sign, and it will be 5 over root 12 plus 7 over root 12 squared, which is 5 plus 7, 12 over root 12 squared. 12 is what? Is root 12 times root 12. So if we cancel one of them, it will be root 12 squared equal to 12. So the answer of this problem is 12. We've solved another problem from senior part that the answer is 12. In junior problems, we don't have minimum, maximum most of the time. It is for senior and open section. I want to solve also one junior. Also, it helps you for open section. It is not minimum, maximum. We have equation. It says find this. So this idea is useful when you have also in IEEE 2022 it was useful. When you have square root, one thing is to raise both sides to the power of 2. It will be x squared minus 4x plus 5 plus x squared plus 4x plus 5 plus 2 times. Now we use what? A minus b times a plus b equals a squared minus b squared. So a here is x squared plus 5, x squared plus 5, and b is what? Negative 4x here and 4x. So it will be what? X squared plus 5 squared minus 4x squared. And we also square right side, which will be 3x squared 9x squared. We can cancel these 4x. It will be 2x squared plus 10 plus 2 times. It is x squared squared. We use what? A plus b squared equals a squared plus 2ab plus b squared. So it will be x to the power of 4 plus 2 times this, 10x squared plus 25 minus 16x squared equal to 9x squared. Okay, now here we take all except square root, we take all things to right hand side. It will be what? So let's consider at first square root. It will be x to square root x to the 4. 10x squared minus 16x squared will be negative 6x squared plus 25 equal to 9x squared minus 2x squared, 7x squared plus 10, take it to right hand side, will be negative 10. Again, we raise both sides to the power of 2. It will be 4 times x to the power of 4 minus this. In 2 steps, in some problems, we should raise to the power of 2. Also for IEEE problems for America, it will be this squared. So it will be 4x to the power of 4 negative 24x squared plus 100 equals this squared. It will be 49x to the power of 4. plus this squared plus 100. Negative 2 times this will be negative 2 times 7, 14 times 10, 140 x squared. Now here we can say we can take all things to right hand side. Okay, 0 equal to, we can cancel these to 100. 49x to the power 4 minus 4x to the power 4 will be 45x to the power 4, and negative 24 if you take it to right hand side plus 24, and negative 140 plus this will be negative 116x squared. So it equal to 0, it will be x squared times 45x squared minus 116 equal to 0. The problem said our equality is this equation. Here, because this times this is 0, if x is 0, if x equal to 0, then 0, 0, root 5, 0, 0 plus root 5 equal to 0, and that's contradiction. So we conclude what this term equal to 0, 45 x squared minus 116 equal to 0. So 45 x squared equal to, take it to right hand side, negative change to positive, plus 116, and x squared equal to 116 over 45. Now let's say problem wants what? The problem says find integer part of this. So we found this, so it will be 116 times 10 to the power of 4, 1, 2, 3, 4 over 45. We should divide. Okay, we can do it in 2 steps, or also you can divide by 45. At first, I divide by 45 is 5 times 9 because it is multiple of 5. I divide by 5. So here it will be 9. This will be 2 times 5, 10, 16. 3 times 5, 15. We have 10, 2, and finish 3 zeros you consider. Now we divide by 9. It will be what? 2 times 9, 18, 52. 5 times 9, 45, 52 minus 45, 7, 70. Because we have 70, then you can say 7 times 9, 63. Again, you have 7, 70. 7, and again, you can 7 times 7, and so on. So the answer of this problem is equal to 25, 7, 7, 7. We've solved this. Okay, now for this problem, these two problems, and also the last one, I want to solve them with one of the most powerful ideas. Is what? Considering a small example, finding the idea. Also, it is useful in round 2 problems. I released the solution of some problems of round 2. If you had any question about them or rest of them, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, so let's focus on this problem. Okay, here the problem says each cell of an 2020 by 2020 table. Okay, we have 2020 by 2020 table is filled with a number which is either 1 or negative 1 for I 1 to 2020. So each cell is, if you draw it, each cell is positive 1. For example, it is negative 1, it is positive 1. And let Ri be the product of all the numbers in the ith row. So if you product all here, it will be R1, and the last one will be R2020. And for column, it says, and let Ci be the product of the numbers in the ith column. So C1 is this, C2 here we have up to C2020. Suppose Ri plus Ci is 0 for I equal to 1 to 2020. So R1 plus C1 equal to 0, R2 plus C2 equal to 0, to the last one R2020 plus C2020 equal to 0. What is the least number of negative ones in the table? So I can say the difficulty of this problem is similar to round 2 of SMO open section. And for both of them, we can solve it with considering a small example. So When I say a small example, it is different. Sometimes, for example, you should consider the size of table. Sometimes you should consider the steps. It depends on the problem. You can check some of them after solving some problems with that. You will get good at them. So here 2020, because it is even, so I consider a small example of even numbers. So here it says what is the least number of -1. So suppose it is R1, it is R2 product of them, S1 and S2. I know R1, sorry, here the problem says C1, C2. So if I consider this, so let's just find one example and then we try to find better examples. The idea of this, don't be afraid of writing. So for example, -1, 1. So if let's have -1 here to not use for both of them and 1, 1 here. And if now R1 is -1, C1 is 1, it's good. R1 plus C1 is 0. Now R2, C2. Yes, if I place here R2 again is 1, C2 is -1. So R2 plus C2 equal to 0. So for 2 by 2 we found 1. Now we try to solve for 4 by 4 to find the best answer. So if I draw 4 by 4, okay, it is R1. So look, we don't want to find only the answer, for example, it is 1. We want to generalize the idea. So here, I saw that if I place -1 here, then it is good for R1 and all of them here, 1, 1, 1. It is good for R1 and C1. And also it is good for C4, if I place all of them 1, for C4 and R4. Now we have problem for what? For these numbers. Again, if I place, let me write this with red. If I place -1 here, this -1 is good because here it is in R2 and in SC2 we don't have that. R2 plus C2 is 0. Why? Because look, it is 1, it is 1, it is -1, it is -1 here. R1 is -1, it is -1, it is 1, it is 1. So we see it satisfies the condition. So here the answer is 2. Now you find the answer. You can guess. You can guess the answer is what? For 2 is 1. For 4 is 2. So we guess for 2020, the answer is what? Yes. 2020 over 2, it is 10, 10. Okay. So now I want to prove. It is for round 1. You can write down the answer. But suppose we want to prove it completely. And maybe it is also for round 2. I want to prove for these types of problem, I want to prove that the answer is greater than equal 10, 10, less than or equal 10, 10. The general way you should prove the maximum or minimum in combinatorics is this. One part most of the time is you should prove it by example, one part with proof. So if you find one example with 10, 10, because the problem says find minimum, then we can prove that the answer is less than this because we found 10, 10 by example. So it is this or less than or equal this, and this one with proof we want to prove. So suppose that we have 2020. So as you saw, we consider -1 here, -1 in this place, until what place? So it is 2020, 2019, until if we cut the middle here, you say until the middle, -1, and except this, let me tell you the middle is what? It's 10, 11, and this one is 10, 11. So from here to here, we have -1. Now we understand what? If we consider product R1 to R10, 11, let me check. It is to 10, 11. Yes. R1 to this. Oh, sorry. Here, if we consider. Okay, so let's check previous ones. We want to use them here. Look, if we divide it to two parts. Okay, so you see, it is 1, 2, it is 1, 2, 3, 4. So it is 10, 11, and it is 10, 10. And 1 R to 10, 10. and these are -1 and the other are +1, or for example 10, 11 is +1, and if you consider C1 is 1 to what to C10, 10 is 1, but from C10, 11 there are -1, which is here +1, and we found the example, so we proved this part. Now I want to prove 10, 10, why the answer is greater than this. So we say R1 plus C1 equal to 0. So R2 plus C2 equal to 0. Because R1, C1, one of them, because it is product, each of them is plus or minus 1. When sum of them equal to 0, so -1 belongs to R1, I say, for example, in first row, I mean this, or -1 belongs to column 1, because if you don't have any -1 in this row, first row, and first column, then some of them will be 1 plus 1. So here, again, you can say -1 belongs to second row, or -1 belongs to second column. Now, if you consider, if I write for last one, -1 belongs to R 2020, or -1 belongs to C 2020. Okay, so if you pay attention, for example, I say what? Let me tell you, like this one to understand, and then I prove here. I say this -1, in R1 we have this -1, R1, C1. Okay. Now for R2, C2, we have this -1. For R3, C3, again, we have this, let me write this -1. I draw it by pink this time. For R4, C4, we have this -1. Okay, as you can see, I calculate each -1 at most twice, because this -1 is in one row and one column. For this row, I've counted that. For this column, I counted that. So, because each -1, we count each -1 at most twice. We have this -1, we count it from here, here. So when I write, for example, I say, okay, we say -1 is in first row, for example, -1 in second row. Okay, so you count how many -1? We count 20, 20 -1s. But for example, suppose that we have k, the number of -1 equal to k. So you counted 20, 20, and each one you count them at most 2k. So you count 20, 20, and each of them is at most, you count each of these k at most twice. So 20, 20 will be what? Will be less than or equal this. So it is the number of greater than equal. You count the number of -1s, you can say, but each number at most twice. So if you have k -1, so if you also calculate all of them twice, the maximum case, it will be this. So we can say the number of -1s will be greater than equal 10, 10. So we proved this part. So the answer is 10, 10. Okay, we've solved this open section problem with considering a small example. Now I want to consider this senior by again considering a small example. In this senior 2021 problem, last problem 25, let's read the problems as what? 40 equal to 2 times 2 times 2 times 5 is a positive divisor of 1440 that is a product of 4 prime numbers. Why 4 prime? 1, 2, 3, 4. Okay. 48 is a positive divisor of 1440. Yes, that is a product of 5 prime numbers. 1, 2, 3, 4, 5. Yes. Find the sum of all the positive divisors of 1440 that are product of an odd prime, look here, odd prime number of prime numbers. So, for solving this problem, let's consider at first prime factorize 1440, because we want to find the divisors. So for 0, because it is at the end of the number, you can say 2 times 5 times 144, which is 12 squared. And it will be 2 times 5 times 12 is what? 4 times 3 squared. And you can say, okay, 2 times 2, 4, plus 1, 5, 2 to the power of 5 times 3 squared times 5. Now, Here, what I mean by considering a small example, I consider, okay, I say I have 3 factors here. 1 factor, 2 factor, 3 factors. So let's consider for each of them. For example, if instead of 1440, we had 5, how many? If we want to find the answer for 5, it will be what? For 5, find the sum of all the positive divisors of 5 that are product of an odd number of prime numbers. So only 5 we have, because 5 is 5 and 1 is odd. So here the answer was 1. If we consider 3 to the power of 2, so here if we consider the divisors, it will be 1, 3, 3 squared. 1 is not good because 0 prime, 3 is 1 prime, it's good. 3 squared is 3 times 3, 2 prime numbers, it's bad. So we checked for 3 squared. Now let's check for 2 to the 5. If we consider the divisors, it will be 1, 2, 2 squared, 2 cubed, 2 to the power of 4, 2 to the power of 5. So 1 is bad, 2 is good because it is 1, 2. 2 squared is bad, 2 times 2, 2 primes. 2 cubed is good because it is 3, 2. It's good. 4, 2, it is bad. And 2 to the 5, it is 5, product of 5 2's, which is good. I'm sorry, it's bad for 2's, it will be good. So 1, 2, 3 numbers. So for 1 prime, we found how we can solve this. So let's consider when we have product of 2 primes. For example, 5 times 3 squared. So there is an important formula when you want to find sum of positive divisors. You say 1 plus 5, 1 plus 3 plus 3 squared, because you can create all divisors. 1 times 1, 1, the divisor of one of these number, 1 times 3, 3, 1 times 3 squared, 5 times 1, 5, 5 times 3, this. Okay, so if we want to calculate this one, so here, if we consider 1, so let's see. If we consider 1 times 3 is good. Because 1 times 3, 3 is a number. But 1 times 1 is bad. 1 times 3 squared is what is not good. Because 3 squared is bad. 5 times 1 is good. Because 5 times 1 is 5 and 5 is good. 5 times 3 is bad. Because 5 times 3, there are 2 numbers. 5 times 3 squared is good. Because it will be 5 times 3 times 3. So we understand that here, if we select the power here, it is, you can say 5 to the power of 0. If the power is even, for example, if I write like this, even and odd, here 3 to the power of 0, 1, odd, and here it is, for example, 0, you select 0, even number and odd number, the result will be odd. So now we found the idea. Here you can say, okay, 5, if I consider 5, 3 squared times 2 to the power of 5, I can write 5 to the power of 0, 5 to the power of 1 times 3 to the power of 0, 3 to the power of 1, 3 squared times 1, or let me write instead of 1, 2 to the power of 0, 2 to the power of 1, 2 to the squared plus 2 cubed plus 2 to the power of 4 plus 2 to the power of 5. Now, I want to select like here, even number, for example, an odd number, because the sum of the powers, we have 0, 5, 1, 3, then even plus odd is odd. So here we can select power even, the result should be odd. Even, odd, 1 odd, so you can say even, and odd, even. And one more case, odd, select here, select odd, odd. And the problem says find sum of all these divisors. So for the first one, let me draw this one, first one, second one, third one, and fourth one. For first one, you say, okay, even 5 to the power of 0 times even again 3 to the power of 0 plus 3 squared times odd, which will be what? 2 to the power of 1, 2 to the power of 3, 2 to the power of 5, plus it was 1. Now, second, 2. If I write even, again 5, 0, odd, 3 to the power of 1 times even, this one even, 2 to the power of 0 plus 2 squared plus 2 to the power of 4, plus the case 3 here, odd, 5 to the power of 1, even, 3 to the power of 0 plus 3 squared, and even here, it will be 2 to the power of 0 plus 2 squared plus 2 to the power of 4. And last one, odd, 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 it will be 5 to the power of 1 times 3 to the power of 1 times 2 to the power of 1 plus 2 to the power of 3 plus 2 to the power of 5. Okay, so let me correct something. Here it was SMO not 2021. It is SMO senior of 2020. Okay, so only this. Now let's solve the rest of that. The fourth part, it is odd, 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 3, 1, 2, 1, 2, 2 cubed, and 2 to the power of 5. So we should calculate it is 1, 1 plus 9, 10 times 32 plus 8 plus 2 times 42, because 32 plus 8 is 40, 40 plus 2, 42. This one, 1 times 3, it is what? It is 1 plus, let's write 16 plus 4, 20 times plus 2 plus 1 is 21 plus 5 times 9 plus 1, 10 times 2 to the power of 4, 16, 16 plus 4, 20, 21 plus 5 times 3 times this one, which was 42, we've calculated here. Okay, if we calculate, the first one is 420, the next one is 63 here, 5 times 21 is 105, and 0 because of this. 5 times 42 here, you can say it's 3. 5 times 2, 10, we have 1. 5 times 4, 20, 21, and it will be what? It will be 6, 3, 0. And now if we add up these four numbers, 0, 0, 3, okay, it will be 3. 3 plus 5, 8, 8 plus 6, 14, plus 2, 16. We have 1 plus 6, 7. 7 plus 4, 11. We have 1. 1 plus 1, 2. So the answer is 2160. Okay, now it's the turn to solve the last problem of this idea. It's junior 2021. Some years were different. I corrected them. It was for 2020, and this one is for 2021. We want to solve this one. The idea for solving this is split up the answer to smaller answers, focus on one property, and this idea is useful in many exams to make sure your answer is correct. So let's read the problem. Okay, a 3 by 3 grid is filled with the integers 1 to 9. An arrangement is nicely ordered if the integers in each horizontal row is increasing from left to right. 1, 3, 7, yes, increasing from left to right. And the integers in each vertical column is increasing from top to bottom. So 3, 4, 6, 7, 8, 9. Two examples of nicely ordered arrangements are given in the diagram below. What's the total number of distinct nicely ordered arrangements? So here, look, let me draw one 3 by 3. Okay, when you see this problem, one of the most important thing is to find the most limited case. So for example here, because it is increasing, strictly increasing. So the minimum one is this and the maximum one is this. So we can say here it is 1 and this one is 9. Now, for the rest of that here, look, if you want to say 2, 2 can only be here or here. And by symmetric, you can say it is not important which of them. You consider 2 is here and multiply the answer by 2. Now for 3. 3, for example, cannot, let me tell you why 2 can only be in these two places. For example, if 2 is here, so this number should be greater than 1, less than 2, and it's impossible. So we consider 2 here and multiply by 2. 3. 3, for example, cannot be here because it is between 1, 2. It is less than 3, so we can't use 1, 2. So the only places for 3 is this place and this place. So now that you know this, you draw one more and say what? Look, you don't say, for example, one answer is this, one answer is this, because in exam you forget one of them. If you use this way, then you are sure you will reach the correct answer. So 3 is here, so let me write 1, 2, or here. Now we are sure that we don't ignore any correct answer. So here. 1, 2, 3, for this case, 4 is here. And if I continue for 5, 5 can be here or here. So let me consider the 5 for this one. 2, 3, 4. 5 is here or here. Now, in this case, when you want to split up, write down exactly at the right time you want to split up. For example, here 5, I draw another table 5. The other one. Here, the minimum one, 6, 7, 8. It is less than this, so 6 should be here. And 7 and 8 have two cases, 7, 8, 8, 7. Here, it is this cell is, let me draw with blue. This cell is not related to these two cells. So here, if you place, for example, 6, it will be what? 7, 8. If you place, for example, 7 here, here it will be 6, what, 8. If you place 8 here, here we have 6, 7. So we have how many cases? 3 cases. Okay, so this one is left. Now we consider different cases of 4 here, 4 here, 4 here. We can see that for here and here, the answer will be same. So let me consider the other case because it has symmetry. So 2, 3, 4 here, we multiply this one by 2, and if you consider 4 here. So if you consider 4 here, these two things are not related to these two things. So we have 5, 6, 7, 8 to place in these 4 places. You say 4, choose 2 for these 2 places. And then in unique way, you place them. For example, if you select 5, 7, 5 here, 7 here, and 6 and 8 here. So it will be 6 cases. If you place 4 here, then for 5, you can have 5 here, 5 here. Okay, so you should know this 2 is for this case. So if I place this one, then I have these 2 for these cases because 4 can be here or here. So if 4 here, sorry, 4 here and then multiply by 2 for 5. 5 here, here. So here you can say, okay, this is not related to this, so you select 3, choose 1 for here, and it will be unique. For this one, 6 is here and 2 cases here. So you say 2 plus 3, 5. 5 times 2, 10. Okay, 10 for this case. 3 here, 2 here, plus 3 plus 2 here, and plus 6 here. So 3 plus 2 is 5. 5 plus 6, 11. 10 plus 11 is 21, and 2 times 21 will be 42. So it was one of the, we can't say it's hard. If you use this idea, consider on one property, for example, places of 2, and like this step by step split it up to smaller answer, it will be easy problem. But if you don't do that, it will be one of the hardest problem, and you are not sure your answer is correct or not. It is not. You can also use, for example, an 8. But you should find one property, one specific property, and say split up the answer with respect to that property. So if someone says, okay, we start from 2, 3. Someone says we consider the middle. So it is not important. Some of them are easier, some of them harder. If you solve some problems, you will get good at it. Okay, so for this idea, we've solved problem from open section, senior section, and junior section. And for SMO 2022, after the exam, I will solve the problems. If you had any question about any problem of SMO 2022, junior section, senior section, and open section, if you had any question, feel free to send message to my WhatsApp number in the description and comments. Okay, thanks for watching the video, and please subscribe, and thanks for your support.